Hi, Lee Wilson. I'm the CEO and co-founder of HonuWorx. We're a subsea robotics technology company based in Aberdeen. So I've been building and deploying all manner of subsea robots for over 20 years. Graduated from the University of Aberdeen, engineer to background. Spent most of my career designing and developing and deploying all manner of subsea robots, predominantly for the offshore energy industry. So we founded HonuWorx with a vision to change the way the world works underwater. Our Halo product, Loggerhead, was developed to deploy and operate subsea robots all without the use of legacy surface vessels, with all of its operators relocated to the safety of shore.
HonuWorx represents one of the most compelling opportunities in the offshore industry right now. If you imagine a current operation offshore which costs between 50 and 100,000 pounds per day, and the cost structure there is a large ship, a crew of maybe 35 people or more, and burning 6, 8, 10 tons of fuel oil per day, and you replace that with an entirely autonomous system powered by a hydrogen fuel cell with nobody offshore, you can imagine there's an enormous cost advantage. And then when you factor in that you're also reducing carbon emissions, you're keeping people safe by having no one offshore, and you're protecting the project schedule from weather and disruptions that you find in the ocean. It's an enormously compelling opportunity and really disruptive. It's going to fundamentally change the way that this sector operates.
Loggerhead is a sea turtle. It's known for its navigation abilities and long endurance. So we've used it as the name of our first product, which is sharing a lot of those characteristics. Loggerhead is really looking to address the costs and emissions associated with traditional deployment methods, which are large ships, which have large crews and they're very expensive, and as I say, there's a large carbon footprint. So by moving to a autonomous system or a variably autonomous system where you can move expertise onshore, you're getting that crew that back on the beach. It's less expensive, and critically, there's a much smaller carbon footprint because the vehicle is completely electric. ROVs are one of the key technologies for working subsea offshore, be that in the offshore energy or defense sector. The Loggerhead system looks to replicate that same technology or the same delivered service, but using a very different deployment method.
For the last 40 years, there's been a huge amount of progress made on the vehicles themselves. The ROVs, they've become a lot more sophisticated in their sensors and their capability. So what they do, they basically have three jobs. They have to inspect subsea assets, maintain them by cleaning them and turning valves, and also doing repair work and installing new parts of structures. So that's their job, and they've got really good at doing that. But the operational model and how they're deployed and operated has always remained the same.
Yeah, so traditionally, subsea robotics are delivered to the field using large crewed vessels. There's a large amount of people that are brought offshore to operate and maintain these systems. There's a large carbon footprint associated with it. So what Loggerhead's trying to do is to change that deployment model but provide the same result. So the Loggerhead system comprises of three main components. We have a mothership autonomous vehicle that's going to sail out to the field. Once in field, it deploys the subsea robot, the ROV, and it also deploys a comms buoy to the surface. And then depending on the operation, that system can either run fully autonomous, or we can connect to an onshore distributed team of experts who can log in and provide certain capabilities. So when the mission is completed, a number of different things could happen. You could plan a new mission and send it off, because this is a very long endurance system, so it can be out for many, many days. Or it would autonomously sail back to the port. There's also a large amount of emergency system handling and safety built into the system from ground up, so it can detect challenges, it can go home when required, it can phone home when required. There's a lot of smarts baked right into the system.
You still need the specialist skills to understand the operation. It's almost like it's the same interface and the same job as you would be on a vessel, except you're just in a different location. Because of the technology, you can swap between different control centers. The owners of the assets can just log in and see exactly what's going on, comment on the operation. It's really exciting technology and a great way to collaborate without everyone just being in the same room, which makes a big difference.
We have a team of people here who've done this kind of work before. It's very niche work, but we have done it. We know what it takes to take a concept and mature it to a product.
And we've learned what works, what doesn't work, and crucially what the customer is looking for, what the problem we are really trying to solve here is.
We have all the bases covered. Each key area that we have to get right, we've got people in the team who've done this before. And it's really, in a way, the convergence of all those skills and all that experience together that is enabling this disruptive approach for subsea work.
So when we first started this and we first shared our ideas, people told us this is not possible. Like, the technologies you need don't exist. So there was a kind of like hold my beer moment where we said, okay, we'll show you. So with our recent trials, what we set out to achieve was to really show everyone that the key component technologies that we need to build a commercial loggerhead are available to us. We showed that we could access a mothership, a large XLAUV platform. We've shown that an industry standard off-the-shelf ROV could be used and be deployed from a subsea mothership. We've shown that the shared autonomy architecture that we've been talking about is viable. We've showed that remote operations is now a routine part of what we do offshore. We've built and commercialized a part of our software stack, which enables remote crews to participate in offshore operations, all from the safety of the office or indeed their spare room. So having proven that the key component technologies are available to us, we now have a very clear pathway to assembling the first commercial demonstrator unit, and we are in conversations with several major customers around pilot opportunities in the North Sea and beyond from 2026 onwards. We've got a very clear view on how we could assemble a fleet of loggerhead systems to take a significant market share in the subsea inspection and repair space. It's a space that's growing rapidly. It's going to be critical to the energy transition, and we cannot do it without robotics. That's very clear. And it is also very clear that the existing model is no longer sustainable.
There's a huge opportunity here, and the limitations of traditional systems, be it cost and carbon footprint, have traditionally been a barrier for a lot of other parts of the blue economy.
This is one of those rare occasions where it's better by every measure. So it's cheaper, safer, cleaner. And that's, I think, unusual. And normally you're having to make compromises around one of those. But I think, you know, the convergence of the technologies that we've been able to bring together and then demonstrate now working with the loggerhead system really will disrupt this market and change how operations are carried out.